Welcome to tonight's video on Unit 8, Part 3. We're talking about the general and unit circle definitions for trigonometric functions. What factors limit the use of right triangle definition of the trigonometric functions like SOHCAHTOA, and why are additional definitions needed? Well, understand that the factors that limit the right triangle definition is that right triangle definition only works with acute angles. Right, so when theta is an acute angle, you can find the right triangle definition. But we need additional definitions because not all angles are acute. All right, so that's why we need the general and unit circle definitions. Before we get to additional definitions, we're going to explore some concepts and hopefully make some connections. So first of all, we'll let P be a point, assuming quadrant 1 for now, on the terminal side of theta, intersecting a circle with radius r. So we're going to draw a circle here. The center is 0, 0. The radius is r. This is a point xy. xy. And then theta goes there. All right, let me make this a little bigger. So now it says draw the reference triangle. So the reference triangle would be here. This would be your reference angle. So remember, theta and theta prime would be the same here. And label the side, so this would be the x coordinate, and the up and down would be the y coordinate. And r is the hypotenuse, the radius. So to find the sine, you would go opposite over hypotenuse, so y over r. The cosecant would be the reciprocal. The cosine would be x over r, and the secant would be the reciprocal. And tangent would be y over x, and cotangent would be the reciprocal. So those are the 6 trigonometric functions of theta for the first quadrant here. Now, while the above problem has a point that is in quadrant 1, an acute angle in a right triangle, this example is easily extended to allow the point to be in any quadrant, and with the angle theta having any measure, because you could make the same reference triangle just in a different quadrant. Doing this gives us the following definition. So the sine is y over r, where r can't be 0. The cosine is x over r. And the tangent is y over x. The cosecant is just a reciprocal. Same with the secant, the reciprocal of the cosine. And the cotangent is the reciprocal of the tangent. And remember, to find r, you would take the square root of x squared plus y squared, because that's the Pythagorean theorem. That would give you the radius. Remember, the radius is a length, so therefore it's always going to be positive, right? Lengths are always positive. So in example 2, it says let the point be negative 2, 5 on the terminal side of theta. So that's going to go into the second quadrant. Right, we'll make a circle here. Right, our point here is negative 2, 5. Here's our radius. And here's our reference triangle. Theta prime is here. Here's theta, the actual angle. And then, so it says, what is the radius? So remember, the radius is going to be the square root of x squared plus y squared. So in this case, r is going to be the square root of 29. And then we drew the reference triangle. Now the lengths, remember lengths are positive, so it's going to be 2 this way, 5 that way. And so when we do the sine for the reference triangle, we get 5 over rad 29, which can be rationalized to 5 rad 29 over 29. For cosine, it's 2 over rad 29, which is 2 rad 29 over 29. And for tangent, we get 5 over 2. And then we just do the reciprocals. This would be rad 29 over 2. And this would be rad 29 over 5. Now, as far as the actual angle goes, the only difference is now the x-coordinate is negative. So that means the cosine and tangent would be negative, and secant and cotangent. The sine and cosecant would be positive because the y value is positive. So here the only difference is that these values are positive, and this cosine and secant tangent and cotangent are negative. All right, so in this question, is theta a acute triangle? The answer is no. Why does the right triangle definition not work for finding the 6 trigonometric functions of theta? Because theta is not an acute angle. In the first problem, theta prime equaled theta because it was the first quadrant, meaning cosine theta equals cosine theta prime. Is this true for problem 2? And the answer is no, because in quadrant 2, x is negative. And then how are the 6 trigonometric functions of theta related, similar, or different? They are similar. Basically, they're the same. Sorry. They're the same values. The only difference is positive or negative depending upon the quadrant. All right, so you should do the next one on your own, and then I'll show you the answers. All right, so if you notice on this one, it's the same values. The only difference now it's in the fourth quadrant because now x is positive and y is negative. But notice the values are the same. The only difference is now the sine is and the cosecant are negative. The cosine and secant are positive, and the tangent and cotangent are negative. So that's the only thing that changed for number 3. All right, so for number 4, we can do this without drawing a picture because now that we have those ratios, sine is y over r, cosine is x over r, tangent is y over x, we have an x and y coordinate here that's on the terminal side of theta. All we need to do is figure out what the radius is. So we just need to find the square root of -3 squared plus -1 squared. So it's equal to 9 plus 1, so rad 10. So now we just apply, so sine is y over r, so -1 over rad 10, which is equal to negative rad 10 over 10. The cosecant would just be negative rad 10. The cosine is -3 over rad 10, which rationalizes to -3 rad 10 over 10. The secant would be negative rad 10 over 3. The tangent is -1 over -3, which is 1/3. And the cotangent would then be 3. All right, so this would be the same thing for number 5. For number 5, notice that when we do the square root, we get negative 4 squared plus 0 squared. So we get the square root of 16, which is 4. So then you're getting 0 over 4, which is 0. Negative 4 over 4, which is negative 1. And 0 over negative 4, which is 0. As far as the cosecant goes, the reciprocal of 0 is undefined because 0 on the denominator. The reciprocal of negative 1 is negative 1, and the reciprocal of 0 is undefined. All right, so go ahead and try the next few on your own. Go ahead and do through number 9, and then I'll show you the answers. All right, so now that you've done those problems, check your answers for 6 through 9. Notice some values are undefined because you're dividing by 0 for number 6. And then number 7, 8, and 9, because the radius was 1, notice that the y-coordinate is just the sine and the x-coordinate is just the cosine. All right, so then the question is, what is special about problems 7 through 9 compared to 2 through 6? Well, if you notice 2 through 6, the radius is a number other than 1, whereas 7 through 9, the radius is 1. So r is equal to 1, and that means it's a unit circle. And that's the definition of a unit circle. So the unit circle is a special case of the general definition when r is equal to 1, because if r is equal to 1, then the sine is just y, the cosine is x, the tangent is still y over x, the cosecant is now 1 over y, the secant is 1 over x, and the cotangent is x over y. So remember, the unit circle is a special case of the general definition. All right, that's when r is 1. So because sine and cosecant are associated with the y-coordinate, in quadrant 1, sine and cosecant are positive. Quadrant 2, positive as well. Quadrant 3 and 4, they would be negative. Cosine and secant are associated with the x-coordinate. So therefore in quadrant 1 they're positive, but 2 and 3 negative. Quadrant 4 positive. Tangent and cotangent are associated with the x and y coordinate. Because remember, it's y over x or x over y. Got to spell coordinate. I'll just leave it as the x and the y. So therefore, in order for them to be positive, the signs would have to be the same. In quadrant 1, both are positive. X and y are positive, so that's fine. Quadrant 2, notice you have positive and negative, so that's negative. 3 is negative and negative, so positive. 4 is negative and positive, so negative. So if you look at number 10, it says, well, first of all, let's go back to this. To remember the trig functions, and I just base this on the 3 main ones, sine and cosine and tangent, because whatever applies to sine is going to apply to cosecant. So if you look at the first quadrant, all of them are positive. Second quadrant, only sine. Third quadrant is tangent. And fourth quadrant is cosine. So I like to say all students take calculus, and that helps me to remember which trig functions are positive in what quadrants. All of them in the first, sine in the second, tangent third, cosine fourth. Talking about symmetry here, let theta be a first quadrant angle in standard position. So if we draw theta here, and it's xy, negative theta down here is negative x, or sorry, it's positive x, negative y, right? So if we look at the sine of theta is equal to y, the sine of negative theta equals negative y, right, in the unit circle definition, because the corresponding point would be negative x and, or sorry, x and negative y. So that means that sine is equal to the opposite, sine of negative theta is equal to the opposite of sine theta, which means it's an odd function, which means it's symmetric to the origin. Cosine of theta is equal to x, cosine negative theta is still x, so that means they're just equal, that means that they're even. Tangent theta is equal to y over x. Tangent negative theta is equal to negative y over x, which means tangent negative theta is equal to the opposite of tangent theta, so they're odd. And that follows, if the sine is odd, then the cosecant is odd. And if the cosine is even, then the secant is even. And if the tangent is odd, then the cotangent is even. Is odd as well. So therefore, this group of identities is called the even-odd identities. And it tells you whether they're symmetric to y-axis or the origin. So these are your even-odd identities right here. So you can add them to your list at the end of the Unit 2 part. Unit 2 note, or sorry, Part 2 notes for Unit 8. Find the angles in radian measure such that the cosine is equal to negative rad 3 over 2. Well, remember, cosine is equal to rad 3 over 2 when you have a 30 degree, or in radian measure pi over 6. So cosine is negative in the second and third quadrant, so it'd be 5 pi over 6 or 7 pi over 6. And since it doesn't specify a interval, that means you could just keep adding 2 pi or multiples of 2 pi to get your answers, and then you just have to say that k is an integer. Secant of 7 pi over 6, well, remember, secant of pi over 6, remember 30 degrees, right? Well, pi over 6 or 30 degrees, remember, if that's 30, so you have 1 rad 3, 2. So remember, secant would be 2 over rad 3 now, or which is 2 rad 3 over 3. Now, if we're talking about 7 pi over 6, that's the third quadrant where it's negative, so it'd be negative 2 rad 3 over 3. For cotangent 11 pi over 6 is in the fourth quadrant. So basically, that is going to be negative of whatever cotangent pi over 6 is. Well, cotangent pi over 6 is rad 3 over 1. So it's going to be negative rad 3. All right. So that concludes our video for this part. If you have any questions, please feel free to ask in class. I'll see you next time. Have a good evening.